Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to see a problem from Mathematical Induction. So let's get going. Problem: if x and y are any two integers, then prove by mathematical induction that x power n minus y power n is divisible by x minus y for all n belongs to natural numbers. Solution. So here we are given x and y are any two integers, then if x and y are any two integers, then we have to prove that x power n minus y power 1 is divisible by x minus y for all n belongs to natural numbers. Here n stands for natural numbers. Let P of n be the given statement. Then P of n will be x power n minus y power n is divisible by x minus y for all n belongs to natural numbers, and for any x, y belongs to integers, or for any integers x and y. So now we'll prove that the statement is true, that is P of n is true for n equals to 1. Okay, if you want, you can try for 2 and 3, and we'll assume that the statement is true for n equals to k. When P of k is true, we'll use P of k is true to prove P of k plus 1. So we have statement P of n x power n minus y power n is divisible by x minus y for all n belongs to natural numbers and x and y any integers. Now let's see for n equals to 1. When n equals to 1, put n equals to 1 in x power n minus y power n, you'll get x power 1 minus y power 1 equals to x minus y, right? X power 1 minus y power 1 is x minus y, which is divisible by x minus y. X minus y ones are x minus y with remainder 0. So therefore, here x minus y is divisor, remainder, this is dividend, and this is quotient. We know that divisor into quotient plus remainder gives dividend. Okay, if the dividend is divisible by the divisor. Okay, so let's see. Divisor into quotient equals to, from this we'll get dividend minus remainder, and quotient equals to dividend minus remainder by divisor. Okay. If the remainder is 0, then we'll get quotient equals to dividend by divisor. Okay, just keep this in mind. Now let's check whether LHS equals to RHS or not. So divisor into quotient plus remainder equals to x minus y into 1 is x minus y plus 0 is x minus y, which is our dividend, right? So here, therefore, x power 1 minus y power 1 is divisible by x minus y, leaving quotient 1. X minus 1, sorry, x power 1 minus y power 1 is x minus y. This is divisible by x minus y, leaving quotient 1, right? Therefore, P of n is true for n equals to 1. Therefore, P of 1 is true. Okay. So you can write this x minus y as x minus y into quotient 1. Okay. Dividend equals to divisor into quotient. And also this is a multiple of x minus y. So we have x power 1 minus y power 1 equals to x minus y into 1. Now let's see for n equals to 2. Substitute n equals to 2 in x power n minus y power n, then you'll get x square minus y square. You can write x square minus y square as x plus y into x minus y, or you can write this as x minus y into x plus y. Obviously it is a multiple of x minus y, right? Now we'll see x square minus y square is divisible by x minus y or not. Since we are having x square minus y square is a multiple of x minus y, so we can say that it is divisible by x minus y. But we'll see using division process, okay? So that we won't get any confusion. We can write x square minus y square as x plus y into x minus y, and divisor is x minus y, since we have to show that x square minus y square is divisible by x minus y. Here x minus y is a divisor, and x minus y into x plus y gives x plus y into x minus y, or x minus y into x plus y, right? So from this we can say that x square minus y square is divisible by x minus y, leaving quotient x plus y, right? So this is a quotient. Therefore, x square minus y square equals to x minus y into x plus y. This is obviously divisible by x minus y, right? See? Where x plus y is a quotient. That means it leaves some quotient x plus y is divisible by x minus y, leaving quotient x plus y. From this we can say that P of n is true for n equals to 2. Therefore, P of 2 is true, right? This is multiple of x minus y. We have x square minus y square equals to x minus y into x plus y. Here 1 is a quotient and x plus y is also a quotient, right? Now we'll see for n equals to 3. When n equals to 3, simply replace n by 3. You'll get x cube minus y cube. We know that x minus y whole cube equals to x cube minus y cube minus 3xy into x minus y. Now bring minus 3xy times x minus y term to LHS, then x minus y whole cube plus 3xy into x minus y equals to x cube minus y cube, right? Now take x minus y common from these two terms, you'll get x minus y times x minus y whole square plus 3xy. So we can write x cube minus y cube as x minus y into x minus y whole square plus 3xy, which is again a multiple of x minus y, right? Now we'll see using division method. X minus y is divisor, x cube minus y cube is dividend. We know that x cube minus y cube is x minus y into x minus y whole square plus 3xy, right? Now we'll see x cube minus y cube is divisible by x minus 3 or not, x minus y or not, okay? So x minus y into x minus y whole square plus 3xy is x minus y into x minus y whole square plus 3xy, or anyhow you'll get multiplying. By multiplying these two, we'll get x cube minus y cube, right? With remainder 0. Okay, so x cube minus y cube is divisible by x minus y, leaving quotient x minus y whole square plus 3xy, right? So from this we can say that the statement is true for n equals to 3. So therefore x cube minus y cube equals to x minus y into x minus y whole square plus 3xy. By saying this, we can say that it is a multiple of x minus y, and also it is divisible by x minus y. Directly you can say that is divisible by x minus y, leaving quotient x minus y whole square plus 3xy, right? This is a quotient. So we got x cube minus y cube equals to x minus y into some quotient x minus y whole square plus 3xy. Therefore P of n is true for n equals to 3. From this we can say that P of 3 is true. Fine. When n equals to 1, we got x power 1 minus y power 1 equals to x minus y into 1, and x square minus y square equals to x minus y into x plus y. When n equals to 3, we got x cube minus y cube equals to x minus y into x minus y whole square plus 3xy. So every time we got some multiple of x minus y, leaving quotients, right? Leaving some quotients. Likewise, for k, you'll get into some quotient, right? Anyhow, we are going to assume that the statement is true for n equals to k. Then we'll get this, right? These are all quotients, and x minus y is a divisor, and these are dividend. Okay. assume that P of n is true for some n equals to k. That is P of k, x power k minus y power k is divisible by x minus y, leaving some quotient, right? That is x power k minus y power k equals to will get into some quotient, or if x power k minus y power k is divided by x minus y, leaves some quotient. Okay, it will be easy, right? From this we'll get right x minus y into quotient, or simply you can write this. Okay, from this statement we can write this, leaving some quotient is nothing but equals to quotient. Okay, anyhow you'll get x power k minus y power k equals to x minus y into, in general form, followed by the first three steps. So here let's name this quotient as some q, say q for quotient. It will be easy to remember, right? X power k minus y power k equals to x minus y into q. Since p of k is true, now we'll show that p of k plus 1 is true. Okay, we have to prove. Whenever p of k is true. Okay, fine. We are having x power k minus y power k equals to x minus y into q. Now, take this minus y power k to RHS, you'll get x power k equals to y power k plus x minus y into q, consider as equation 1. Or multiply both sides of this equation with x, then you'll get x power k into x equals to x times y power k plus x minus y into q. Then you'll get, add the powers, you'll get x power k plus 1 equals to x into y power k plus x q into x minus y, consider as equation 2. So from the assumption we'll get two equations, x power k equals to y power k plus x minus y into q, which is our first equation, and x power k plus 1 equals to x y power k plus x q into x minus y is our second equation. Now we'll prove for k plus 1 using either this or this. We'll show in both the cases. For n equals to k plus 1. So here we have to show that p of n is true for n equals to k plus 1 whenever p of k is true. Okay? P of n is true for n equals to k plus 1 whenever p of k is true. Well, now you can split x power k plus 1 as x power k into x minus y power k plus 1 as y power k into y is equals to, now replace x power k using equation 1, since x power k equals to y power k plus x minus y into q. Then you'll get y power k plus x minus y into q into x minus y power k into y, which is equals to x into y power k plus x cube into x minus y minus y into y power k. Now write the terms involving y power k firstly, then you'll get x power x into y power k minus y into y power k plus x cube into x minus y. Now take y power k common from the first two terms, you'll get y power k times x minus y plus x cube into x minus y. Since we are having x minus y in both the terms, you can take x minus y common and you'll get x minus y times y power k plus x cube, right? We got x power k plus 1 minus y power k plus 1 equals to x minus y into y power k plus x cube using first equation. Now let's see what we are going to get using the second equation. Is equals to, since x power k plus 1 equals to x into y power k plus x cube into x minus y. Replace x power k plus 1y, x into y power k plus x cube into x minus y minus, you can write y power k plus 1 as y power k into y is equals to, now write the terms involving y power k, x into y power k minus y into y power k, and the remaining term x cube into x minus y. Now take y power k common from the first two terms, you get y power k times x minus y plus x cube into x minus y. Now take x minus y common from these two terms, you'll get x minus y times y power k plus x cube, right? So we got the same thing by using equation 2. So you can use any of these two equations to find x power k plus 1 minus y power k plus 1. So now we got x power k plus 1 minus y power k plus 1 equals to x minus y into y power k into x cube, right? Here let's see whether x power k plus 1 minus y power k plus 1 is divisible by x minus y or not. Obviously it is a multiple of x minus y, so it is divisible by x minus y. But let's see clearly in division method. So we know that x power k plus 1 minus y power k plus 1 is x minus 1 into y power k plus x cube. X cube. So x minus y into y power k plus x cube gives x minus y into y power k plus x cube, where x minus y is divisor, x power k plus 1 minus y power k is dividend, also x minus y times y power k plus x cube is also a dividend, and is a quotient, right? So x power k plus 1 minus y power k plus 1 is divisible by x minus y, leaving quotient x y power k plus x cube, right? Therefore this is a quotient. You can name it as some lambda if you want. Okay, then you'll get x minus y into lambda. Therefore x power k plus 1 minus y power k plus 1 equals to x minus y into lambda is divisible by x minus y, leaving coefficient or leaving some coefficient lambda. Okay, from this we can say that therefore P of n is true for n equals to k plus 1. Therefore P of k plus 1 is true whenever P of k is true. Right? From this we can say that by the principle of mathematical induction, P of n is true for all n belongs to natural numbers. Okay, so here we always got quotient, right? Multiple of y leaving quotient. I am saying that this quotient is also an integer, right? So here lambda belongs to z, and earlier when n equals to k, here you are having q, right? Here q is also belongs to integer. Okay, let's see how. We'll see some examples. So here we are given that x belongs to integer and y belongs to integer and belongs to natural numbers, right? And we have to get x power n minus y power n by x minus y equals to some quotient, and I'm saying that this quotient belongs to integer. So let's see how we are going to get integer. Let's choose integers x and y. We'll choose distinct integers. Okay, distinct integers is nothing but x is not equals to y. X is different and y is different otherwise. So we have integers, set of integers, right? Now let's see some cases for x greater than y. Okay, so let's take x as 2 and y as minus 1. X equals to 2 and y equals to minus 1. Here x is greater than minus 1, right? Sorry, 2 is greater than minus 1. That is x is greater than minus 1. So from this we'll get x minus y equals to 2 minus of minus 1. That is minus 1. 2 plus 1 equals to 3. When n equals to 1, x power 1 minus y power 1 equals to x 2 power 1 minus y minus 1 power 1 equals to 2 minus of minus 1 equals to 2 plus 1 equals to 3. Then x power 1 minus y power 1 by x minus y gives x power 1 minus y power 1 by is 3 and x minus 1 y is 3. This is equals to 1, which belongs to z. Okay, we'll write it later. Okay, for this we got 1. Fine. Now let's see for n equals to 2. When n equals to 2, find x cube y cube. Sorry, x square y square equals to x square minus y square equals to 2 square is 4 minus 1 whole square is 1. 4 minus 1 is 3. So x square by y square gives x square minus y square by x minus y gives 3 by 3, which is equals to 1. Right? Now we'll see for n equals to 3. When n equals to 3, x cube minus y cube equals to 2 cube minus of minus 1 whole cube, which is equals to 2 cube is 8 minus minus 1 whole cube is minus 1, which is equals to 8 minus into minus plus 1. 8 plus 1 equals to 9. Then x cube minus y cube by x minus y gives 9 by 3 is 3. Okay, so here we got quotients 1 and here 1 and 3, right? Okay, it belongs to natural numbers and also integers, right? Only I'm talking about these 3 numbers belongs to natural numbers, but I am saying that this quotients belongs to integers. Okay, we'll use some other example to make it clear. We'll choose 3 and minus 4 now. 3 minus 4. Obviously 3 is greater than minus 4. Now from this we'll get x minus y equals to 3 minus of minus 4 equals to 3 plus 4, which is 7, right? Now when n equals to 1, we'll get x power 1 minus y power 1 equals to 3 power 1 minus of minus 4 power 1 equals to 3 minus of minus 4. 3 plus 4 equals to 7. So from this we'll get x power 1 minus y power 1 by x minus y equals to 7 by 7 equals to 1. When n equals to 2, x square minus y square equals to 3 square minus of minus 4 square, which is equals to 3 3s are 9 minus minus into minus plus 4 4s are 16. Minus 16 plus 9 is minus 7, and x square minus y square by x minus y gives minus 7 by x minus y is 7, which is equals to minus 1. Now we'll see for n equals to 3, x cube minus y cube equals to 3 cube minus of minus 4 cube equals to 3 cube. 3 3s are 9 and 3 is 27 minus of minus into minus is plus, again plus into minus is minus, simply minus into minus into minus is minus into minus, plus into minus is minus, right? So we'll get minus 4 4s are 16, 16 4 64 is equals to 27 plus 64 equals to 91. Then x cube minus y cube by x minus y is 91 by 7. 7 1s are 7, 7 3s are 21. So this is equals to 13. So identify the quotients now. When n equals to 1, 1 is a quotient. When n equals to 2, minus 7 is a quotient. Minus 7, no. Minus 1 is a quotient. When n equals to 3, 13 is the quotient. So we got 1, minus 1 and 13. Obviously, all these numbers belongs to integers, right? So from this we can say that from the problem which we have proved, we got quotients, right? We got some quotients in the problem, q and lambda, which are also integers. If you want, you can check by taking some distinct x and y, you'll get some lambda and q also. The quotients belongs to integers when x and y are distinct integers and n belongs to natural numbers. That is, we'll get quotients or integer quotients when x and y are distinct quotients and n belongs to natural numbers. So we'll get the quotients which belongs to integers whenever x power n minus y power n is divided by x minus y for all distinct x and y, distinct integers x and y, and n belongs to natural numbers. So we have seen a problem from mathematical induction in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.